Good in the back? Anybody that cares? Okay, great. Good afternoon. Good afternoon. I know we got the blood sugar issue hitting. We've had lunch. We've had water. There's not been much caffeine. We're all sitting. So, do I need it? We can get up and do jumping jacks here for a second if we need to. My name is John Brown. I am an operator of a network based in Albuquerque, New Mexico. We run basically fiber to the home, fiber to the business. One of the things that scares the bejeezers out of me is, great, I'm putting fiber to these wonderful homes. They're getting full gigabit. It's a symmetrical pipe. Wow, packet rate. All kinds of fun things. So we're working on trying to figure out ways to help make the network better and make sure that our customers aren't causing other people pain. And so we do various bits and pieces of things. One thing I wanted to talk about is source boost packet filtering and some things that we do in our network that might be applicable to help others mitigate stuff. I do not believe that there's a silver bullet that solves all problems. Fiber isn't going to solve all the problems. Wireless isn't going to solve all the problems. A firewall doesn't solve all the problems. So your mileage may vary based on the things that we do here in applying them into your own networks or making recommendations to others. The other little caveat that I would throw out there is before you implement something, you should always turn it up in a lab, test it, make sure you understand what its implications are to your network. A little bit about me. I'm based in Albuquerque. I will travel for packet food and really good single malt scotch. The rule about scotch is, of course, you never drink scotch less than half your age. I'm getting expensive. I'm a technology trainer for several vendors. In a past life, I was a technical lead for ICANN to LRoot DNS for about 3 years. Basically took over that role after the 2002 DDoS that hit all the routes. That was kind of fun. I've built some ATM networks. My network, we've got about 700 BGP peers. We're in LA, San Jose, Ashburn, and soon we'll be at AMZIX. So how do we prevent bad packets, sorry, typo there. How do we prevent bad packets on our network? You can write ACLs. I mean, that's what everybody sort of immediately thinks about in the small, mid-sized service provider market. You can put them on the edge, and they're very easy to maintain, especially when you have hundreds of routers to deploy this across. Not. So there's got to be a better way to do this. And one of the ways that we do is we leverage BGP as a signaling protocol, and we leverage Unicast reverse path forwarding as a second way of helping prevent and do things on our network. And we'll talk a little bit about each of these. First, let's talk about uRPF, Unicast reverse path forwarding. So it's defined in RFC 3704. That's the current RFC that I found out that it talks about it. There were a couple of previous RFCs, but the current one is 3704. Basically, Unicast reverse path forwarding is designed to limit the impact of source spoofed packets. So the gentleman up here from Perimeter X is sending me a packet, but it's coming to me with a source IP address that's not on his network. Then he's potentially spoofing that packet. Okay? So what Unicast reverse path forwarding will do is we'll look at that packet, we'll look at the source, and we'll look in our routing table. We'll make a determination as to, is that source packet reachable back down the same interface to him? If it is not, drop. If it is, forward. Some people will say uRPF is Unicast reverse path filtering. It's not filtering, it's a forwarding. It's making a forwarding decision, to forward or not to forward. Okay? And so there are people out there that will say, well, we can't put uRPF in our service provider business because it's going to break things. The world's going to fall apart. It's difficult. It's hard. I mean, I've heard these arguments on the NANOG list and various other lists. I'll tell you, I've got thousands of edge connections. We run uRPF on every one of them. Do I get complaints? No. We drop the traffic. If it doesn't come from an IP that I've given them, I drop it. Now, what do I do when I have a multi-homed customer that's running BGP? Yes, I have a little bit of a different world I have to work with. But when I'm looking at DSL or cable modem-faced or wireless ISP-faced edge customers, your 80-20 rule, if you want to think about it that way, 80% of those interfaces I can protect to make sure that I don't get unicast source spoofed packets coming in. Everybody here know who CADA is, or CADIA? A research, Casey Clafferty and crew down, what is it, UCSD? Yep. They have a tool that you can implement into your network that will actually do spoof checking. And so we run a little tool that they have that sits there, and once a day, once a week, whatever their time period is, they try to spew spoofed packets out the door towards their collectors to see whether or not we're blocking them. And generally, they don't ever get past. It's like the Roach Motel, they never leave. I believe that if we implement BCP 38, we prevent source spoofed packets, we're going to see a good chunk reduction in what happens on our networks and what's happening as far as abuse. As I said a moment ago, how does it work? But real quickly, we make decisions on the destination is what a router is usually doing. It's looking up that destination. We're not looking at the source. So the attacker is leveraging the fact that we're looking at things, a forwarding decision based on destination IP, not source. uRPF lets us now look at that source address. We can look at it and do things in two modes. We can do something in strict mode. We can do it in loose mode. Strict mode says that if it absolutely didn't come from this gentleman, drop it, if that's not reachable back. Loose mode says, well, it's not directly down this interface, but there is a route in my routing table that says that that source is a real source. So I'm going to still allow the traffic to flow. Okay? If the source is reachable, then good, else drop. Now, here's an interesting thing. In loose mode, if the next hop is null, which your routing device thinks is the null interface, it will drop the packet in hardware. So I can turn around and throw things away by just making sure that next hop to a bad address is null. Switching. BGP black holing. This is the opposite. I'm the upstream ISP. I'm going to say I'm big ISP, and I don't know. What's your name, sir? Eugene? Eugene's my downstream ISP customer. I'm big ISP, and I'm flowing a whole bunch of attacks towards one of his web-hosted customers. We know the destination IP, but I'm saturating his 1 gig link to the upstream world because of all this malicious traffic flowing in towards him. All right. One way he can solve that is he can pick the phone up and ring me up and say, hey, would you please drop traffic to 1.2.3.4 because that's my customer and they're getting attacked, but it's eating up the rest of my bandwidth. Now he's got to wait for me, the customer service rep. Okay, what was your name? Eugene. How do you spell that? And what company are you with? And what, you all get the point, right? It takes a while for that to happen. Now, if we have established a BGP session between us, he can actually use BGP as a signaling protocol to tell me automatically to throw that traffic away. So he can tag a route and send it to me with a pre-agreed upon a BGP community string or community tag, and send that to me. When I receive that route from him, I will set next hop in my router to dev null. So now all of a sudden that malicious traffic coming into his subscriber 1.2.3.4 is being thrown away upstream, and hopefully the rest of his pipe is back up and the bulk of his users are back up and they're happy. You've pushed the problem upstream. Your victim is really now a victim, but it's sort of the lesser of two evils, right? You've killed one to protect the rest of your network. You can use BGP to tell others, whether they're your peers or your transits, to drop traffic. So now let's say your customer's getting DDoSed. You can go through the black hole, as I just went through, and now off you go. Sometimes I get ahead of my slides. I apologize. So let's see what happens if we can start to mix some of these together. If we enable strict mode uRPF on your single home customers, we'll prevent source spoofed packets from entering the network. This will help DDoS victims out there. So I'm not making money on it when I enable uRPF on my interfaces. I'm helping Eugene's network. I'm helping make sure that my network isn't causing a problem for somebody else. And I think this is a mindset that we have with some service providers, is it's not really killing them, so why do they care and why do they need to push this across their network? It's that their business is actually impacting everybody else. I talk a lot to small rural ISPs, and a lot of them have their backbone connections or over microwave fixed wireless connections. And so they're spending money on time slots to send that traffic down across their wireless backbone. So if we can help them figure out ways of fixing that upstream, that helps save them money, it helps save them bandwidth capabilities. I will stress these points. Make sure that you test these things in a lab before you start deploying them. But I can't just drop everything. If I drop everything, my customer will be dead. Can't I just write an ACL? Yeah, you can write an ACL, drop 3,000/32s, build that, deploy that across a whole bunch of routers, and then your attacker realizes that you're now blocking those, so we'll go ahead and spin up a different set of IPs. What we can do is we can use uRPF loose feature. We can inject a route into the FIB with a forwarding information base, and we can set that route to be black hole or null. And now what happens is your router will look at the source IP address and will drop based on that source IP because it's in the FIB pointing to dev null. So now, instead of necessarily Eugene telling me to kill traffic going towards his customer, if there's a way for me upstream to be intelligent about looking at all this traffic, maybe I see a whole bunch of just SYN floods, and I can extrapolate out the bad SYN requests versus good SYNs, I can then drop all those bad SYN source IPs in my big service provider network heading towards him. His customer is still up and running now. In fact, some of the BGP scrubber guys, that's what they will do. So we inject a source IP, we set it to next hop to be black hole, and then poof, basically our traffic from that source goes away. And you can use tools to inject. So what do we use to inject? I'm a big open source person. If I can do it in open source, I'd rather spend the extra bit of time to set up open source than necessarily buy a commercial package. Because I think a lot of the stuff has already been solved in open source. We know it's round, it rolls, it's called a wheel. Let's use open source if we can. So have an injector machine. Put routes on that you don't want to receive from. These would be sources. Tag those routes with a couple of communities. You definitely want to make sure you tag it with no export, because what I don't want to see happen is I don't want to take that /32 that I think is a bad actor IP and announce it to Cogent, my transit provider. Because all of a sudden now, if Cogent's BGP filters aren't set up right, I'm going to see a lot of traffic for that /32 coming into my network. More importantly, someone's probably going to complain and say, hey, wait a minute, why are you announcing my space? So you want to set no export. You also want to make sure that your production routers have specific, explicit filters in place that do not cause these prefixes to leak out of your network. Routes can be updated on the injector. All your BGP edges, devices will start dropping from that source. Caution, caution, caution. I wanted to put the little warning, Will Robinson robot up here, but didn't have time to do that. RFC 2119 defines words like must, shall, may, should, and in this case must. You must not redistribute this source. Must make sure your BGP filters drop these prefixes. And I again strongly encourage you to test before deployment. What can I use as a BGP? You could use, I think Bird is one of them. You can use Exa-BGP, that's what I use. I like Exa-BGP, it's free, it works. It has JSON support, API, you can control it from a variety of different methods. and you can run it on simply something really simple and stupid, low-cost piece of hardware. We have a SQL database that we put routes into. We have a whitelist table. We have a blacklist table. We do some aging of those IPs that we get. We wash, before we push it into Exa-BGP, we wash it through our whitelist to make sure we don't accidentally drop well-known sites, etc. So that's basically what my presentation is all about. Last week we had a DDoS. It was an NTP attack against one of our downstreams, 2.5 gigabits per second. You know, not really that big in the grand scheme of things. We had about 18,000 /32s that were hitting us. We grabbed those, we injected them into our BGP. Within a couple of minutes, that downstream ISP was no longer feeling the pain. We were dropping traffic from those IPs at our edges to the rest of the world. When we saw that the attack went away, we were able to turn around and pull those out and move on. If we see IPs that keep coming up in our list, we keep putting longer age out times on them and just let them sit there for a while unless somebody comes and screams. I work on the squeaky wheel principle. If you really don't like me dropping that traffic, you'll call me up and yell at me about it, and we'll talk about why I was dropping and what you should do to not have me drop it in the future. Other than that, I know I kind of just buzzed through this fairly quickly. I don't think it's a super advanced topic, but thanks to Gotti and the rest of the folks that putting this together, and to our sponsors, Intel, Salesforce, Duo, Baylor, etc. There's where you can find me, and I stand for questions.
How does your system handle spoof sources with millions and trillions of different source IPs?
We haven't gotten to millions, but the core routers we have are memory-wise are able to handle large quantities of inject. We've gotten up to around 100 and 120,000 source spoofed on one attack. So I haven't stressed it up to millions.
And knowing the system automatically blocks source IPs, have you ran across a situation where somebody targets you using well-known services like spoofing Google, spoofing Microsoft Azure, or something like that, to cause your system to automatically cause your customers to not be able to access those systems?
That's why we have the whitelist. So we try. It's never going to be perfect. None of this is perfect. We try to have well-known services, IP addresses in there. Has somebody gone out and tried to figure out what is our perimeter tools, and then what's the weakness and all of that? No, we haven't seen that. I'm sure in about an hour I will. Go ahead.
My last question is, you said that it doesn't benefit you or reduce any cost for you because you're not paying for the bandwidth of your downstream providers. Do you see that this helps you monetize or bring customers in, or say you're a more secure network? Like it costs money, time, and resources to deploy the system, but what is the benefit?
So let me qualify. What I was saying that it doesn't benefit, doesn't make us money or cost us money, stuff like that. Basically, I was using that as an excuse that I've heard from other big service providers say why they haven't done source spoof filtering on their network. For our position, when we turned on uRPF about 2 years ago, we saw about an 8% drop in our overall traffic. So from our benefit perspective, I believe we're running cleaner pipes now. And I know that my downstream ISPs are happier because we're able to, they can either use BGP to tell us to drop something, or we can see something that happens and we can go ahead and drop that traffic, and it keeps them up and running when they're in Durango, Colorado. I think it was...
Have you tried BGP Sec?
BGP Sec, no I haven't. In the back.
What percentage of your malicious traffic is spoofed versus just a bot that's not spoofed?
I don't have a good way of looking at that yet. I'm in some of that analyst world. I am but Padawan learner, which is the other reason why I'm here today, is to try to suck up as much knowledge as I can and come in with the position of I run a network. How do I help make my network better to put you out of a job, which will never happen. But you know, I want to be able to build a better mousetrap on the service provider side.
So, I mean, when we're taking it smooth like these at like in an edge, do you think as IoT and like more variety type contents where it really doesn't matter not smoothing IPs, you just have millions of these endpoints? Is that going to effectively be a disincentive to get uRPF actually deployed across the world? Because hey, you don't really need to fix it now. It's too big a problem to fix.
I think part of it comes down to, at least from the school of the internet that I've been involved with over 20 some odd years, you know, don't do stupid things on a network and don't cause harm. And if there's literally a 1-2 line insert you can put on an edge interface, and you can get your junior tech to start rolling that across each community, each region, et cetera, to help prevent that, then you sort of get rid of that problem. I mean, I guess the flip side would be, somebody earlier today was using medical as an example as to the way we're thinking about and trying to solve some of these problems. And hey, we got really great hospitals, so who cares about cholesterol? Probably can still live after the heart attack because there's good drugs and good hospital for it. Or should I be taking and eating better so I don't even have to go there? I would say that I don't care if you're the largest provider in the world down to the smallest, you shouldn't allow traffic into your network that is faked. And we have the same problem in the VoIP telephony world, right? We have tons of spoofed caller ID and origination phone numbers. We've got to solve that problem too.
So it sounds like you're working pretty much in a reactive model at this point, wholly reactive?
Mostly reactive. I do get some data feeds from a few folks that I trust that I'll take those IPs in, they'll tell me their command and control bots, other things along those lines, and we'll just throw them into our system and drop traffic. What we're playing with there real quick is we're now working on where we can set next hop to actually go over here to a sensor. And so I can see, oh, hey, wait, Billy Bob over here is now trying to communicate to this CNC. What's going on with Billy Bob, and can I help Billy Bob clean up their environment?
Yeah, so have you thought about taking, I mean, this is probably, you know, it sounds like you're running large core routers, but taking flow feeds off of them to get a picture of what your customers' normative traffic profiles look like so that you can then take that data and alarm on it when you see a spike that's out of their norm and maybe actively respond. Maybe touch base with them and say, you or one of your customers have something going on.
Right.
Special, or do you think this is attack traffic and you want to do something about it?
We're playing with NFSend and some other flow, NetFlow stuff to be able to get smarter about that. And most of that's in internal development code-wise. In other words, me and one other person as we run the business and have time to do some coding. So yes, I would love to be able to sit there and look at what is a normal state for a particular customer's connection. When do we start going outside of various thresholds on that and alarming? We are doing that right now purely on bit rate and then also on packet rate, because I consider the two of them very separate indicators. I think the gentleman in the blue suit? No?
I was just going to follow up. The benefit we see, the question on why use uRPF, is that for ISPs and service providers, it frees up bandwidth in your core.
Yep.
To not use uRPF says my bandwidth isn't worth it. If you do use uRPF, that reduces the bandwidth in your core needs. So that's why you should, regardless.
Yeah, so you can then you can convert that into a monetization that's a savings, or I don't have to buy more capacity. My capacity purchase time now just got pushed out 6 months, 12 months, what have. Right. Other questions, comments? Green.
Have you looked at the flow spec?
Pardon?
Have you looked at the flow spec?
At FlowSpec, we're playing with it. We haven't completely dived into it. I've been more of a NetFlow person because historically we've been a Cisco shop, and over the last 12, 18 months we've migrated over to the J company. We're running a bunch of fairly good size MXs now, and we're happy. My last GSR 12,000 will go out to the shooting range in a couple of weekends, and we're going to see what the Barrett 50 does to it. It's not bulletproof. Other comments, questions? Is this not a bad idea to do? Is this a bad idea for us to be doing? Is this good? You think this is good? Okay. Yeah? Wasn't that called Telstra? No. We'll get Jeff Houston to do it all over again. One of the things is I don't know if there's researchers that are in the community here, but one of the things we have done with a couple of folks is because we can steer some of this traffic off to a collection device, is we're happy to work with researchers. If you're a real bona fide researcher, send me something in PGP, and I'm happy to work with you and chat. It's my network. I'm the guy that makes the decision, so there's not much in the food chain. Other comments, questions? Okay, well, thank you very much.